All right, hey guys.
Hello.
How we doing? Oh, Mr. Bedell is here somewhere. Where is he?
Where's
He's
Waldo?
wearing his Where's Waldo shirt today. Can't find him. All right, guys. Hey, this is not much of a jump,
Nope.
really. When you look at the formula,
Yeah.
it's not much of a jump. It's a different concept, but the formula itself is not that big of a change here. So we're talking about pyramids. Find the volume of pyramids and cones.
Yeah.
In this section, and so when we're talking about volume of a pyramid, really both of them.
Yeah.
Both shapes are 1/3 of what we just talked about in the last section.
Yep.
And maybe we can do that in our classes. Talk about we have these kind of shapes and so on where we can fill them with water, and you can see how when you fill up a pyramid of the same dimensions as a prism, that you fill up 3 pyramids and it fills up the prism with the same volume of water. So the 1/3 is the only difference. So as you look at that formula, the volume equals base times height. The area of the base times height just has a 1/3 in front of it. And so this example is a little bit unique because it has a triangular base too.
Yeah. Yep.
That's not what makes it a pyramid, but it just happens to have a triangular base to this one. So we're just going to go through the formula. We're going to find the area of the base. The capital B is the area of the base, remember. It's a triangle, so the formula for the area of a triangle is 1/2 little b, base times height. And so if you look at that base, it's a right triangle. So the small b base is 4, height would be 6, and so as we go to plug that capital B in there, we'll end up with 1/2, because that's part of the formula, of 4 times 6 for the triangle. The 1/3 is in front of it because that's from the volume formula that we're plugging into overall here. Okay, and then the height of the pyramid itself, remember, is the perpendicular height to the base, and so in this diagram that would be a 9. And so again, we're just doing arithmetic here. And
Big thing I want you guys to remember, though, is this is not surface area. So when it asks for the height, guys, when we did pyramids and surface area, we use the slant height. This is back to the perpendicular height again. So that's a significant difference between surface area of a pyramid or a prism, a cone or a pyramid, versus the volume of a pyramid or a cone.
Yeah, good point.
So be careful there.
Good point. It has to be back to a perpendicular height.
Yep.
Perpendicular to the base.
Perpendicular base.
So, okay, not just an edge of the base. So if you kind of look at this, though, the 3 and the 2 on the bottom, when they multiply, they'll cancel with that 6 up there, because multiplication is commutative, so it doesn't matter order. So really this ends up being 4 times 9. Ends up being 36, and again we're talking about volume, and so it's cubic meters in this case. And so once you plug into the formula, it's just multiplying through.
Yep.
Okay.
All right, so volume of a cone, guys, is 1/3. There's that 1/3 again, and pi r squared is like saying the area of the base, but we just take out the b and put pi r squared in there because we're dealing with a circle.
We know it.
Yeah, remember the other day I said that typically the cylindrical type shapes with the circles in them, they're the easiest ones because pi r squared never changes. That's
Right.
what circle is.
Right.
And so once again, it's the area of the circle times the height from the tip all the way to the base down there. So it's pretty straightforward. The area of the circle times the height, the perpendicular height. So if we want to find the exact volume, now remember when it says exact volume here, we're going to leave it in terms of pi. So just that makes it a little bit easier actually. So if we look here, we've got the formula 1/3 pi r squared times the height. So they give me the height is 4.5. Now I know this looks a little bit weird, but remember you can visualize that 4.5 is a perpendicular with that base down there. So that's still the height because it's the perpendicular from the tip at the top to the base at the bottom. We're looking for that perpendicular. So it's 1/3 pi, 2.2 is the radius, so 2.2 squared times 4.5. And there it is right there. Okay. So basically this is 2.2 squared times 4.5 divided by 3, and then attach a pi at the end of it. And you're going to get roughly 7.26 pi centimeters cubed. And I don't think it goes to the approximation. No, it doesn't. So anyways, if they wanted the approximation, guys, all you got to do is go 7.26 times pi in there, and it'll give you the approximation.
Yeah, and this is a little different cone. The fact that
Yeah.
it's not a right cone like we talked about in the last section, finding the surface area. The surface area it does have to be a right cone. Here, it's not a right cone. The point of the cone is not at a right angle right above the center of the circular base, and so it's kind of a skewed off cone. But that's okay for finding the volume. We can do that.
Yep, as long as it makes perpendicular.
Yep. Yeah, the height. Yeah, as long as the height's perpendicular. So here's another cone. This is a right cone in this case because the point is perpendicular to the center. And so find the volume to the nearest hundredth place. So basically the same thing we just did. We're just not doing it exactly. We're rounding off here.
Uh-oh.
Yeah. A little bit more complicated process, though. Why would they give us an angle?
Oh, no.
I don't know either.
Lost use trig.
So we're going to have to use some trig here. We learned that in the last chapter, that when they give us an angle inside of a right triangle, we got to use some trig here. So let's start plugging into the formula. Volume
think
equals
it's-
1/3.
Just when you think it's safe to go out and play with the
I know.
the
You
cone.
got to remember something from before. Hate that. So 1/3 pi r squared h is our formula. So the 1/3 and pi stay there. Radius we don't know, though.
Nope.
So that's why we got to use our trig to figure out. So looking at that right triangle there, we have the 65 degrees, we have the 16 feet as the one leg. We need the other leg of that right triangle, so we're going to use tangent. And so I'm assuming off to the side here somewhere, they have tangent of 65 is equal to the opposite over the adjacent, so 16 over r. So remember, when you have one with the variable in the bottom, those two switch places, and so it's 16 divided by tan 65. And so that ends up giving us approximately 7.46. So that 7.46 is the radius of the circle of the base of the cone, and so we're going to put that up into our formula for the radius. We're going to end up squaring that, and then the 16 comes from that perpendicular height of the cone. And so they've already put that 16 in. So now there's the full formula with everything plugged in. And so because they want us to find it in the nearest hundredth place, you just got to put all that into your calculator. So it might be easiest to square the 7.46 first, multiply it by pi, multiply it by 16, divide the whole thing by 3. And you should get approximately 932.45 cubic feet for the volume inside of that cone. It's a large cone.
Yep.
Holds a
It's a
lot.
big cone.
Yeah.
There's some that I like that they do here that I just want to mention, and that is they look at the information they have here in the second pink step,
Yeah.
and they put in what they know, and so then you can see, oh, I need the radius, and that may help you guys figure out, oh, what do I got to go back and find, and then you can look at that and say, wait, there's no way I know that, now I got to think of something else.
Gotta
So
use a different tool.
yeah, it's always important to really plug in what you know, what you need in the formula, and then just figure out those pieces you don't need, and then you can go through and finish the problem. So it's just a good way to kind of eliminate things
Yeah.
when you're going through this.
And probably a typical example there would be that they would have given us a slant height and the perpendicular height and asked
Right.
us to use Pythagorean
Sure.
to get r.
Right,
So
for sure.
whatever tool you need.
Yep, got to be able to do that.
Yep.
All right, now for the granddaddy of pyramids. This is a pretty involved problem here, guys. So strap in and be ready to see a lot of
It's
math.
a long
going here.
example,
Yeah.
so keep up here.
Whenever you see a polygon greater than 4 sides on the bottom, typically it's going to involve a lot of work. And so with this one right here, we have a hexagonal pyramid, and we want to find the volume of that. And so here we go. So the formula is the volume is 1/3 the area of the base, which is a hexagon this time, times the perpendicular height. So once again we see that we have 1/3, and then we take out the area of the base and we plug in 1/2 AP for the area of a polygon, and we're gonna and then they substitute in the 11 because that is the perpendicular height to the base. Okay, and this is like that cone that I did earlier, where it's not directly over the center, but it is a perpendicular right there at the right, so we can assume that height is 11. Okay, so now what do we need? Well, we need the apothem, and we need the perimeter. Well, the perimeter we can figure out real easy because it's one side is 4 times 6 is 24, so we get that, but we still need that apothem. So you're going to have to take the hexagon out like that, okay, and then we got to figure out that mid-seg or that segment down there at the bottom, or sorry, the perpendicular apothem out of that triangle. So what we're going to do is we're going to make we know that that's 2 because that's half of the side, which is 4, okay? And so now we're going to go 360, okay, divided by 12, all right? And it's 360 divided by 12 because
it's got 6 pi
there
pieces in
we
there,
go.
but then they
There we
split it
go.
in half to get that little triangle. You guys should remember this from the
Yeah.
last chapter. We did this over and over again in chapter 11. And really, a hexagon is one of the easier shapes
Right,
to do this in.
right.
So that's where the 12 comes from.
Yeah, I was thinking 360 divided by 6
Six,
sides and then
yeah,
cut that in
and
half.
then split that in half.
But they're already splitting that in half based on that little triangle because there would be 12 of those right triangles in there as you went through and swung this around. So anyway, so we've got 360 divided by 12, okay, and that's going to give us a 30-degree angle up there at the top. Okay, and so now we're gonna use trig here again, since now we know that it's a 30-degree angle. Oh, actually, we don't have
Or
to
you
because we
could do
30,
the-
60, 90.
That's why
Yeah,
hexagon is one of the easy ones.
yeah,
It's a 30,
exactly.
60, 90.
So we have a 30, 60, 90 here. So if the short leg's 2, okay, then the longer leg is 2 root 3. okay? Or they're gonna use trig here.
Use trig, either way.
And so they do tan 30 equals the opposite over the adjacent, and they get 2 root 3, which, remember guys, it's the long leg of a 30, 60, 90, so we can also say it's 2 root 3 if you want to use that shortcut, or you could go right to this if you don't remember those rules. Now that I know A, I'm just going to take A out of the formula that I have there in the white, pop that in there, okay, and so now I have volume is 1/3 times 1/2 of 2 root 3 times 24 times 11. Now there's a lot of canceling out that you could do
Yeah, it looks
throughout
complicated, but
this.
it's not.
You know, the 1/2 and the 2 could cancel each other out, and the 1/3 could go into the 24 8 times, and so you get rid of your fractions altogether, and then it's just a matter of multiplying across.
It's just 88 radical 3.
Yeah, just 88 radical 3 right there, and then, you know, that's the exact answer because it's in radical form, but if you wanted the approximation, just multiply it through, and there you go.
Yep. So we'll do more examples, just like every other section. We'll look at finding volumes of these types of shapes in class.
Yeah, I mean, if you can do any of these ones that ever have a hexagon, pentagon, whatever on the bottom, you pretty much know your stuff.
Yeah.
So,
Okay, guys, we'll see you in class.
bye.